The next question is problem 8.45. So this is a scenario type question. We've got our data within the words, so let's read through the question first and try to quickly identify what type of question we're being asked to do. So we're told a study conducted by the Australian Stock Exchange found that 46% of 2,405 Australian adults surveyed in 2006 held shares, either directly or indirectly through managed or self-managed superannuation funds. So straight away at this point, the information I'm focusing on is the 46%. There's been a survey, but we've got this 46%. So I'm thinking, well, proportions. Percentages are a good indication that we're dealing with proportions, and a quick sort of reread of the question tells me that yes, in this context I'm not talking about means, I'm talking about the proportions of adults that own shares. So although it's a fairly long sentence, the key information is the 46%. It's our sample proportion from a survey of 2,405 Australian adults, and really the rest of it is just sort of extra information. It's that 46% as a sample proportion that's the key information. Now part A is the first task. We're asked to construct a 95% confidence interval for the proportion of Australian adults who held shares in 2006. So keywords, 95% confidence interval. We know it's a confidence interval question, and even if we hadn't identified that it was about proportions from the original question information, there's no doubt the question actually says here in part A we're doing a confidence interval for the proportion of Australian adults who held shares in 2006. So this is a proportion question. Now, confidence interval for proportions, well, there really isn't any choice. The only ones we've looked at are those using the normal distribution. So it's pretty much a question of just writing down that key information so that we have quick access to all the numbers we need. Just need to then get the confidence interval formula that's specific for a proportion, substitute everything in and do the number crunching. So if we have a look at the values, our sample proportion P is 46%, so 0.46 as a decimal. Our sample size was 2,405. It's a 95% confidence interval that we want to complete. For proportions, we use the Z distribution, so the normal distribution. You could draw up the diagram if you wanted, but we've already seen a Z diagram for 95% when we did means earlier in problem 8.8. So straight away I can tell you that the corresponding Z score is 1.96, so that's our critical value. And it's really then just a matter of looking at the formula. So specifically for proportions, the confidence interval will be sample proportion P plus or minus the critical value Z times standard error. So there's always that general format for a confidence interval. It's always going to be point estimate plus or minus critical value times standard error. Probably by the end of this tutorial you'll be sick of hearing me say it, but remember that's the general format. It's then just a matter of knowing the customized version for our particular application, and here it's proportions. So sample proportion P plus or minus the Z value times standard error. We know P, we know N, we know Z. Substitute everything in, so our P is 0.46, the Z value is 1.96, and then the standard error is based on knowing P and N. Still a good idea to calculate the Z times the standard error component separately. It comes out at 0.02, so 1.96 times the square root of our P times 1 minus P over N. If you put all of that into your calculator, you end up with the bit that we're adding and subtracting equal to 0.02. Add that to your point estimate to get the upper boundary of 0.48. Subtract it from the point estimate to get the lower boundary of 0.44, and we have our confidence interval. Now remember, this is the confidence interval for the population proportion. Population proportion is represented by pi. So I can now say to you that I am 95% confident that the true proportion of Australian adults who held shares in 2006, so i.e. the population proportion, is between 44% and 48%. So that's our confidence interval. Again, we've used our sample result, this time a sample involving proportions, to say something about the population. And here we wanted to say something about population proportion pi. So that's part A. We've got part B, which is simply to interpret the confidence interval we've just created. Now there's sort of two things we need to do in a standard interpretation of a confidence interval. So part B you can actually think of as a good sort of template answer. When we get our confidence interval, the first thing is, if you're trying to interpret it, is to just write down what we've been saying in words. So to say, we are 95% confident that the proportion of adults who held shares directly or indirectly in 2006 was between 44% and 48%. That's just the standard putting the confidence interval into words. To make sure we really show that we truly understand what the confidence interval is telling us, it's important just to clarify what we mean by the 95% confident part. Now remember, that percentage, when we calculate just one confidence interval, it either contains the true population proportion or it doesn't. So it's either right or wrong. But we've said we're 95% confident it does contain the true population proportion. So what is that 95%? Well, you can think of it as like a long run average. So basically we're saying if we did this whole procedure, say 100 times, we would expect 95 of the confidence intervals to actually contain pi, the population proportion, and therefore 5 of them we would expect not to contain it. Whether this is one that contains it or not, we would never know unless we had the entire population data. But it gives you an idea of, if you wanted to use this in some kind of analysis or to make a business decision, you need that probability so you know, well, what are the odds that it's correct? And so you can think of it in that long run average context. So part B just gives us the opportunity to sort of make sure we have that understanding. We have one more part, part C, and part C is in fact another calculation question, but it is related to what we've been doing with confidence intervals. Now remember, with confidence intervals, they're based on having a particular sample size, but we have learned that the bigger the sample we take, the more accurate the results are going to be. And in terms of confidence intervals, there's a relationship between the width of the confidence interval and the sample size. So we can in fact rearrange formulas to solve for n and pretty much work backwards and say, well, if we want a confidence interval of a particular width, how big would the sample have to be? And so as you can see in part C, we're asked to construct a follow-up study. Well, we're told we're going to do a follow-up study to estimate the population proportion of adults who currently hold shares to within plus or minus 0.01 with 95% confidence. And this time, it's not the interval we're coming up with, it's, well, how many adults would we need to interview and ask to be able to get that level of accuracy. So here in part C, we're actually specifying that the confidence interval should be plus or minus 0.01. How do we do that? Well, let me just go to the next slide where I have my working.